Hey everyone, Mr. Fritz here, and in this video we're going to talk about the tangent function. Just kidding, I'm really a person, not a hand. We're going to graph the tangent function. We have graphed the sine function, the cosine function, and the tangent function is up next. And this one is completely different. So get ready to burst your brains and let's do something new. So let's just dive right in by going back to the unit circle. First thing I want to think about is, now in this unit circle I have put my tangent values. Remember in the unit circle the x values are my cosine of theta and the sine would be the y. Tangent you can calculate by dividing sine over cosine, or y over x. And what I want you to think about is what is going on with the tangent values as I move around the circle. And I also want you to think about what is going on, or when does the pattern of these tangent ratios start to repeat itself. So let's address the first thing first. What's going on? Well, as I move around in this direction, and I look at root 3 over 3, 1, root 3, those numbers are getting bigger and bigger and bigger and bigger and bigger. And then I have this undefined. Okay, I don't know what that's equal to, but I have numbers that are getting bigger, and then all of a sudden it's undefined. And remember that is because I'm dividing 1 by 0. Can't do 1 over 0, so that's where we have this undefined. Then when I move past that undefined point, I have very similar numbers that are kind of like reflected, but because they're negative, I'm still getting bigger. So negative root 3 is less than negative 1, which is less than negative root 3 over 3. So these numbers are all increasing as I go around the circle. And that would continue if I followed this direction as well around quadrants 3 and 4. I'm getting bigger and bigger and bigger, and then I have this break, and then I'm getting bigger and bigger and bigger, and then I have this break, and I'm getting bigger and bigger and bigger, and I have this break. So there's some sort of a pattern going on where we have something kind of interrupting our increasing going on. Okay, that's the first thing. The second thing I want to talk about is, when does the pattern repeat? So if I'm looking at my tangent values as I rotate around this thing, I have I'm going to start here at 0. I'm going to move until my pattern repeats itself. Well, here is the first tangent in that sequence again, 0. And it looks like I am matching up root 3 over 3 with root 3 over 3, 1 with 1, root 3 with root 3. So it looks like this is where my pattern starts, and this is where my pattern starts. So I've actually, it's only taken me pi radians, or 180 degrees, around the unit circle before I begin my pattern, or before I begin my tangent ratios again. Compare that with like our sines or cosines, where I had to go all the way around the unit circle before I saw the same exact ratios before. That's what come into play when we graph this thing. So it takes only half as long before I restart this cycle. Okay, still visualizing, still getting a handle of what the tangent looks like. I've got a little bit of a Desmos visualization to kind of grasp what's going on with the tangent function, since we can't actually see it necessarily on the unit circle. We know that the cosine of theta is my x value in for my coordinate on the unit circle. We know that sine of theta is my y value. And if I move this thing around, we can see how those values change. One thing I want you to think about is what the size of the ratio of the sine, or the y, over the x will become as I move this thing around. So for example, right now, the sine is clearly smaller than the cosine. Well, if I have a small number and I divide it by a large number, the result would be something even smaller. As I continue to move around, once they are the same at about 45 degrees, when I divide this by this, that's equal to 1. And when I continue to make the sine very, very large and the cosine very, very small, now I have a large number divided by a really small number, and that's actually going to result in a larger quotient. So here's what I mean. Let me go back to 45 degrees, and while we can't actually see the tangent in the unit circle as I have it here, I want us to visualize the tangent as being tangent, literally tangent to the circle, a line that is tangent to the circle that begins at the point on the unit circle, and it stretches out until it meets the x-axis. So we can think about it like that, because the length of this line is actually equal to the ratio of the y value over the x value. Kind of nice. As I move this smaller, we can see that that length is getting smaller for my orange line. That should make sense. As I'm getting larger, my sine value is increasing, my cosine is decreasing. This number is getting bigger and bigger and bigger. And then what's going to happen is if I'm actually tracing this to my x-axis, think about when I make a tangent that is at the very top of my circle at 90 degrees or at pi over 2 radians. There's no way that this is going to actually touch the x-axis, right? So I have like an infinite length for this orange line here. That's kind of weird. Something funny is happening here. And then as I continue to move around, we get smaller and smaller, smaller, and then it starts small, grows, then it gets smaller and smaller and smaller after I have this weird infinitely long line thing again. So the tangent is something that's going to kind of be growing and shrinking and growing and shrinking and growing and shrinking in kind of a weird way. So holding on to all of that, let's now talk about how we can actually make a graph out of this.